Hello students, welcome to LearnGuru Classes. So last class we were discussing about the ways to identify a rational number, how to convert a fraction into equivalent decimal expansion, and we have learned about the terms terminating and non-terminating decimal expansion. So today we will be dealing with some statements. Okay, so some statement will be given to you and you have to say whether the statements are true or false along with justification. Now this type of statements come in your exam. Okay, so it may be either of 1 mark or 2 to 3 marks will be awarded against this type of statements. So you have to frame your answer according to the marks. Okay, so I will mention you as I proceed further how much to write for against what marks. Okay, so with that note, let's start the class. So the first statement is every whole number is a natural number. Every whole number is a natural number. Okay, so you have to say whether this statement is true or false and you have to justify your answer. Okay, along with that, okay, so this is the statement and it has come in, means it is the example of chapter 1 in the NCERT book. Okay, in your NCERT textbook. Plus it is available in our R.D. Sharma also. Now, what are the set of, let us come to the solution. What are the set of whole numbers? The set of whole numbers are 0, 1, 2, 3 and the list continues till infinity. I am not writing here infinity. What are the set of natural numbers? The set of natural numbers are 1, 2, 3 and it continues till infinity. Now, what is given? Every whole number is a natural number. Means each and every numbers contained in the list of whole numbers should be a natural number. So let's check. 0 is a whole number. So is it included in the set of natural number? No, it is not included in the set of natural number. So what can you say? That every whole number is not a natural number. So we will write that since 0 is not included in the set of natural numbers, therefore every whole number is not a natural number. Hence, the statement is false. Okay. So, if it comes for 1 mark, then you can write from this to this. And if it comes for more marks, of course, you have to show this the entire thing. Okay. So, is it clear to you? Yes, it's very easy. Okay. Now, let's move to the next statement. So, the next statement is every integer is a rational number. So what is the definition of rational number? Rational number is a number that can be represented in the form of P by Q, where Q is not equal to 0. Okay? So rational number comprises of fractions and integers, isn't it? Integers. So integers may be 1, 2, 3, 4, 5, isn't it? 6 and -1, -2, -3 are the examples of negative integers. Now 3 is an integer. 3 is an integer that can be represented by 3 by 1. Yes, 3 can be represented by 3 by 1, isn't it? Where P equal to 3, Q equal to 1, not equal to 0. So 3 by 1, representing 3 as 3 by 1, it resembles the expression of a rational number. So we can say either it is a positive integer or negative integers. Any integers can be expressed in the form of P by Q, and since it can be expressed in the form of P by Q, we can say that every integer is a rational number. Okay, so what can you write? Since integers can be represented in the form of P by Q, where Q not equal to 0, therefore every integer is a rational number. So the statement is true or false? Of course the statement is true. Statement is true. Okay. So let's move on to the third statement. The third statement is every rational number is an integer. Okay. So rational number is a number that can be represented in the form of P by Q, where Q is not equal to 0. Rational number comprises of fractions and integers. That means integers are a type of rational number. Fractions is a type of rational number. Am I right? So, what is given? Every rational number is an integer. So, this statement is not true, because since rational numbers consist of fractions and integers, so and fraction is one type, integer is of one type, though both of them are rational numbers, but we cannot say fraction is same as the integer, and hence we can say that all the integers or all the rational numbers are not integers. Okay, though integer is a type of rational number. Integer is a type of rational number. Fraction is a type of rational number, but all the rational numbers are not type of integers. Understood? So, what will you write? Since rational numbers are of two types, that is fractions and integers. Therefore, okay, I will write, therefore, every integer is not a rational number, is not a rational number. So the statement is false. The statement is false. Okay, so if it comes for 1 mark, you will write this to this, and if it is for more marks, so obviously you have to write the entire thing from this to this. Okay, so let's move on to the fourth statement. The fourth statement is every natural number is a whole number. So it is there in the exercise 1.1 of chapter 1 in the NCERT book. Okay, so what are the set of natural numbers? Set of natural numbers? Tell me. 1, 2, 3, and the list continues. What are the set of whole numbers? 0, 1, 2, 3 till infinity. So every natural number is a whole number. 1 is a natural number, it is also a whole number. 2 is a natural number, it is also a whole number, isn't it? So in this way, whatever list of numbers are there as natural numbers are also whole numbers. So what is this statement? True or false? The statement is true. Why? Since all the natural numbers are also whole numbers, therefore every natural number is a whole number. So, therefore, the statement is true. The fifth statement is every integer is a whole number. Okay, so integer is a type of rational number. Then integers are again divided into positive and it is divided into negative integer. Then positive integer is again divided into natural number and whole number, isn't it? So write down what are the natural numbers. 1, 2, 3, 0, 1, 2, 3. Negative integers are -1, -2, -3, -4. So I have classified integers as positive and negative integers. So from the classification itself, the thing is clear to you. Is that integer is divided into positive integer, negative integer. Positive integer is again divided into whole number and natural number. So whole number is a part of positive integer. Positive integer is a part of integer. So we cannot say that every integer is a whole number. Whole number is a type of positive integer. Positive integer is a type of integer. But we cannot say that all the integers are whole numbers, because integers consist of positive and negative integers. So the statement is false. So how will you write? Since integers consist of positive and negative integer, therefore every integer is and you have to write about where the whole number is placed. Integers consist of positive and negative integers, and whole numbers are only a part of positive integer therefore every integer is not a whole number. Statement is false. For 1 mark you will write from this to this, and for more marks you have to show the entire classification as well. Okay, so let's move on to the 6th statement, that is the last statement. So the last statement is every rational number is a whole number. So let's again classify rational numbers. So rational number is divided into fractions, into integers. Integers are again divided into positive, negative. Positive is again divided into natural number and whole number. So this classification makes it clear. See the position of whole number. Whole number is under positive integer, positive integer is under integer, and integer is under rational number. So what can you conclude? That every rational number is not a whole number, because whole number is a type of positive integer. Positive integer is a type of rational number. Okay, so what can we say? Since rational number consists of fractions and integers, whole numbers are only a part of positive integer therefore every rational number is not a whole number. So the statement is false. Okay, so the statement is false. So for 1 mark you will write from this to this, and for more marks you have to write the entire thing. So this is the pattern of the statements that will be coming in your exam. So these statements are not limited to only these type of statements are not only limited to only these 6 statements. Any combination of the numbers I have taught you may come in your exam. So if your concepts are clear, then you will be able to answer those, or otherwise it is not. I will show you a easy method how to remember this type of combinations to say whether these statements are true or false. Okay, so let's move to the method. To have a better understanding of the concepts of this type of statements, I have shown a simpler method to remember this, where I have taken 4 circles of different sizes. Okay, so the black one is named as rational number. Rn stands for rational number. Then comes the red one, comes smaller than the black one, so that is named as integer. Then comes whole number, and the smallest one is the natural number. Okay, so what can you say from this? You can say that since rational number, the circle named as the rational number is of bigger size, and it contains all the other circles of smaller sizes, isn't it? So rational number, integers contain whole number, natural number, then whole numbers contain natural number. So in this type means what? Rational number, since rational number is of bigger size, chances of finding more varieties of numbers are more. Then integers, compared to rational number it is smaller, but compared to the other 2 circles it is larger. So the possibility of finding some more varieties, or compared to the rational number it is less, but probability of finding more varieties of numbers are more. So in this way same comes whole number, natural number. Since natural number consists of very small size, so the chances of finding more varieties of numbers of different types is less. Okay, so what does that mean? I will take the convention that we can move from natural number to whole number. We can move from natural number to integer. We can move from natural number to rational number. Okay, so similarly we can move from whole number to integer. We can move from whole number to rational number. And since after integer the next bigger circle is rational number, so we can move from integer to rational number, but backward from bigger circle to smaller circle we cannot move. So this is the thing that you should remember. Rational number is the biggest circle, natural number is the smallest circle. You can move from rational number to whole number, that is from bigger circle to smaller circle, but the reverse is not allowed. Okay, so this is the convention. Okay, so here natural number to whole number, natural number to integer, natural number to rational number, whole number to integer, whole number to rational number, then from integer to rational number. So from that, what can you say? Every natural number, since you can move from natural number to the bigger circles, you can say that every natural number is a whole number, is an integer, is a rational number. Understood? Understood? Every natural number, as you can move from natural number to all the other numbers, you can move from, means you can go from smaller circle to the bigger circle. So whole number is bigger than natural number, integer is bigger than natural number, rational number is bigger than natural number. Okay, then every whole number, come to the whole number. Every whole number is n or a. From whole number you can move to integer, you can move to rational number. So what can we say? Every whole number is n or a, integer and a rational number. Again, every integers, from integer where can you move to? You can move to the rational number. So what can you say? Every integer is a rational number. Okay, so this is from smaller to bigger circle. Okay, now let's move to the bigger to the smaller circles. Okay, which is not allowed. From bigger to smaller circle, it is not allowed. Means this is the convention that I have taken for better understanding of the statements. So from bigger to smaller circle. What can we say? Rational number is the biggest circle. So you cannot go from rational number to integer, from then to whole number, then to natural number. So what can we say? Every rational number is not integer, is not whole number, is not natural number. Every integer is the next circle. Every integer is not whole number, is not natural number. Then comes every whole number is not natural number. So can you match this term with the first statement? Every whole number is not natural number. Is it happening? Yes. Can you match it with the fourth statement? Every natural number is a whole number. Yes. Every integer is a rational number. The second statement. Yes, you can match this. So if you have a better idea about this diagram, about the entire thing, then I think solving statements of any kind will not be a problem to you. Okay, I request you to pause the video and copy the entire thing written on the board and paste it on the wall, so that everything is clear to you like a picture. Understood? So the key point of remembering is that rational number is the biggest circle, then comes integer, then comes whole number, then comes natural number. Another convention is that you can go from, means rational number is the biggest circle and natural number is the smallest circle. So you can move from smaller circle to bigger circle, but you cannot move from bigger circle to the smaller circle, and the rest is just the same. Okay. So today we come to the end of this class. If you find this video helpful, please subscribe to LearnGuru Classes, like and share it with your friends and relatives. So thank you very much. Bye bye.